And here we're going to talk about Lyon Metro. Lyon is a city in the south of France. And in 1992, they started the deployment of driverless trains in Lyon, the Metro and Line D. That's one of the main lines on the Lyon Metro. It's 8 miles long, it's got 15 stations, and it carries a total of 80 million passengers a year. So it's a very serious metro line. Subsequent to that, Lyon Metro looked at other possibilities to introduce automation. The goals of the automation are really operational efficiency. Could the frequency or the speed of the trains be increased? Or from a cost side, are there operational or capital cost reductions that are possible? And the third critical area is really related to safety and reduction of risk. So what Lyon Metro did was looked at a whole system which implemented a series of sensors which are aimed to detect whether or not a passenger or an object has fallen onto the track. And here's how they work. So if you look at the diagram in the top right, you see there that there's a number of parallel horizontal infrared beams across the railway track. These are approximately 6 inches apart, and they run the whole length of the platform. And if these beams are cut, the signal goes first of all to the train, the driverless train, coming down through the tunnel, and also to the operations room. So if one of the infrared beams is broken, then nothing happens. This is considered to be a false positive. 2 adjacent beams are cut, then the train is automatically stopped before it comes onto the platform. If the incident is more serious, and that is determined by 2 adjacent beams plus a third sensor being cut, the system assumes that that's more serious, stops the train coming into the platform, but also switches off the power to that section of the track, again to protect anyone that might be on the track. And the third case that's here is again even more serious, where some of the sensors are tripped at the edge or going into the tunnel. This implies an intrusion that someone has entered the tunnel, and in this case the whole of Line D shuts down. So very serious. And members of staff then need to, the process is they need to go into the tunnel to actually go and do visual checks as well. So this solution was developed by Viveris, one of PRQA's partners in France. It was developed according to EN 50128 and also 50126 and 50129, a combination of all 3. It was done using MISRA and QAC, and it was deployed during the period from 2011 to 2013. And we've got a full case study that describes the whole of this process. I think one of the most important things is a comment there from the technical manager in the project from Viveris. He was saying that it was critically important that they had a software tool that was verified. First of all, it accelerated the development times. Secondly, it actually reduced cost, that investment. And thirdly, probably more important, it mitigated their risk.